This mission has quite a history. It was originally planned to launch about 2004 or 5 or so, but then the Columbia accident occurred, and the administrator at the time decided that this would not be a safe thing to do, because what most people don't realize is that every time the shuttle launches, it goes someplace now. It goes to the space station. It's a different inclination of orbit. To go to Hubble, you go to a different orbit. And if something goes badly on this mission, you cannot get to the space station. There's no safe haven, so to speak. The shuttle people, to their credit, found a way to make this a safer mission, and that is, the way you do that is have a second space shuttle on the launch pad ready to go and rescue the astronauts if it's determined that there was a problem with the first orbiter, some debris hit or something that would risk their lives coming back into the atmosphere. So that's why you'll see 2 shuttles on the launch pad. Lyman Spitzer, Dr. Lyman Spitzer. He's called the father of the Hubble Space Telescope because he wrote a paper back in 1946, which was published. He was working at the RAND Corporation at the time during the war, just after the war. And it was a paper looking at the German V-2 rockets and saying, you know, with this capability of launching things into space, wouldn't it be great to launch a telescope into space and get it above the atmosphere and not have the atmosphere mess up the images and be able to see ultraviolet and X-ray light? I first got involved with Hubble. It was actually called a space telescope in those days, back in 1976, when I took my first postgraduate job at Princeton University and worked for Lyman Spitzer, the father of Hubble. I wasn't working on Hubble in those days. Lyman Spitzer was, but I was involved in lunchtime conversations, so I got sort of a dose of Hubble from 76 to 78. Then I joined NASA headquarters in the astronomy program, and shortly thereafter, in 1979, I became the chief scientist on Hubble, and I filled that role basically from that point on until I started getting promoted. But I've never been in a job since then where Hubble wasn't under my purview, so to speak. So I guess 31 years of direct purview and 3 years of pre-graduate work, so to speak. We got to the launch date in April of 1990, and I'm positive that if we all had written down the 100 most likely problems with the Hubble Space Telescope, if everybody involved with Hubble had written down those top 100, not one of them would have listed the mirrors the wrong shape. So that's not a positive story. It's kind of a weird story, but it's a true story. That led to 3 years of absolute hell for all of us. Hubble became, it was in the press all the time with the problems. It was a billion-dollar mistake. People in the press called it a technological disaster, a national disgrace. Late-night comedy hosts were making jokes about Hubble. Cartoons would appear with Mr. Magoo as the true inventor of the Hubble Space Telescope. Nobody really, people tried to cancel it. In the meantime, the Hubble team, we worked quietly for 3 years. We promised back in 1990 that we had a way to fix it. We put a new camera in with corrective optics in it that would cure the optical problem. Nobody believed us, but we promised that we'd do it, and would do it by December '93. And we launched the mission, SM-1, on December 2nd. I'll never forget that day, 1993. And after 5 EVAs, spacewalks, the astronauts came home, and about 2 weeks later, we took off the bandages from our eyes, and suddenly Hubble was fixed. It was totally fixed. Hubble, you know, we knew Hubble was going to be important even before it was launched, because it represented a factor of 10 times more power to astronomical capability in terms of resolution, how sharp the image is, in terms of how faint you could see, than any current ground-based telescopes back in 1990. 10 times doesn't sound like a lot, but it's a huge number in astronomy. The last time we went a factor of 10 in capability to see the sky was all the way back in the 1600s, when we went from the eye to Galileo's telescope. That represented a factor of 10 increase in capability. Well, was that important? Well, let's see. Before Galileo, we believed the Earth was the center of the universe and everything rotated around the Earth and nothing could go around any other object. They all had to go around the Earth. Galileo, one of the first things Galileo did was pointed his telescope at this bright light in the sky. He didn't know it was Jupiter, but it was Jupiter. And he saw 4 dots. And the next night he saw that they moved. And then after night, he saw that they went around Jupiter. Well, this can't be. This is not what our textbooks say. It basically led ultimately to the Copernican revolution, the Renaissance, and the way we look at ourselves. I mean, it had profound effects on society, the way humans looked at themselves. It was a scientific, a philosophical, a psychological, a theological result. We knew Hubble would have some effect, but nobody could have predicted it becoming an icon, a world icon in terms of science, in terms of education. You can't pick up an astronomy textbook any place on Earth, I maintain, if it's been published in the last 10 years. And it doesn't matter if it's published in Arabic, English, Spanish, Lithuanian, or whatever. I guarantee you that book will be filled with Hubble images because they have become the standard for excellence. In addition, Hubble's been adopted by the American people, especially school children. When the final servicing mission was canceled a few years ago, kindergarten kids, grade school kids were writing in postcards saying, please save the Hubble, save our telescope. It's just become part of American society. I maintain that the 300 million Americans, if the average American knows or has heard of one scientific project or instrument in their entire lives, if it's only one, I'll bet you that would be the Hubble. I've seen all of the Hubble launches. I've seen a lot of shuttle launches, but the Hubble launches, of course, are special. Knowing that this is the last one, knowing that I've spent an entire lifetime on this, there'll be a lot of nostalgia, but I won't feel any pain because there are many things that people can work on in their careers. I could have gone into other fields. I could have been an engineer, and maybe my contribution to society is I could have designed the first cell phone that broke the 3-ounce barrier, and only weighed 2.95 ounces. In 100 years from now, maybe my grandchildren would consider that a major breakthrough. I have a feeling 100 years from now, Hubble's still going to be in the history books. And knowing their granddad worked on Hubble and was heavily involved in it, I think leaves a legacy that I'm kind of proud of.
T-minus 6, 5, 4, 3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
Mission Control, Houston.
Roll program. Roger, roll, Discovery.
The roll minute.
It sure looks like I want to go to starboard. Starboard, yeah. I'd go ahead.
And we see first motion. Looks good.
And as the crew just confirmed, we're seeing both blankets beginning to unfurl on the port side solar array.
So far we see good smooth motion both sides. Go to filter state.
We concur, Charlie.
Sorry, I was taking pictures. You want? I may have missed your call. You want to go ahead and do RMS power down so we can get the guys out of the airlock? Is that affirmed?
But that's at your convenience, Steve. But once we do have the RMS stowed, then we'll back out of EVA.
Okay. I'll tell you what. We'll spend just a few more minutes then getting some pictures here.